Hello children and welcome to the class of science. We are discussing chapter number 12, electricity, and we have discussed about electric current and potential difference. In the previous video lesson, we also discussed about electrical components and the symbols which are used for these electrical components to draw in an electrical circuit. In today's video lesson, we are going to understand the relationship between electric current and potential difference. In 1828, George Simon Ohm, a German physicist, he derived a relationship between electric current and potential difference. And this relation is called as Ohm's Law, which is supposed to be very famous in the field of electricity. Certain formulas in physics are so popular that even without the knowledge of these formulas, we end up memorizing such formulas. In the field of modern physics, it is E is equal to mc square, which is so famous. Similarly, in the field of current electricity, it is the Ohm's law about which we are going to study in today's video lesson. So, Ohm's law is a relationship between the potential difference across the conductor and the current flowing through the conductor. And potential difference we apply across the ends of the conductor with the help of the cell and the battery. Ohm's law states that the current flowing through the conductor is directly proportional to the potential difference between its ends, provided its temperature remains the same. Alright, when we say direct proportion, meaning is that both the quantities are dependent on each other. If you increase one quantity, the other quantity increases. If you decrease one quantity, then the other quantity also decreases. So symbolically, we can write like this: I is directly proportional to V, or V is directly proportional to I. We can also write it like this: V upon I is equal to constant of proportionality, and this constant of proportionality is denoted by letter R. So V upon I is equal to R. From this, I get the formula V is equal to IR, and this is the most famous Ohm's law. So henceforth, the moment I say Ohm's law, the formula which should come in your mind is V is equal to IR. Now in this formula, R is the constant of proportionality, and it is called as resistance for a given metallic wire at a given temperature. Alright, so now let's understand the verification of Ohm's law. Verification of Ohm's law means we will verify whether really voltage or potential difference and current are interdependent on each other. Verification of Ohm's law is one of our experiments in physics laboratory. For that, we will be making use of the circuit diagram, which is shown here on the slide towards the left side. Check the connections there. We have used batteries, a key, ammeter to measure current in the circuit, and voltmeter to measure potential difference in the circuit. So other diagram is we will be using these components in our physics lab, and the left side is the circuit diagram which for our understanding. Alright, so this particular part is battery. When the cells are connected one after the other, they form a battery, and in the pictorial representation you can see this. Then this is plug key. In our physics laboratory, the plug key we will be using this. Then an ammeter, which is used to measure the electric current in the circuit, and this is an ammeter which we will be using in our lab. And a voltmeter to measure potential difference, and here is the voltmeter. So the circuit connections goes like this. You can see all the components are connected to each other with the wire, and we have used a nichrome wire here. Alright. Now let's understand how the experiment is performed. The experiment is, we are checking how electric current and potential difference are interdependent on each other, and this is verified by Ohms, so it is called as Ohm's law. Have a look at this circuit diagram. You can make out that one cell is connected in the circuit. Alright, and if you see this, the plug key is out. That means it is off. The plug key is off. Means there is no current flowing through the circuit, isn't it? Because we have not plugged in the key into the hole. And when there is no current flowing through the circuit, the ammeter is showing reading as 0, and the voltmeter is also showing the reading as 0. So this is our first step to connect the components to each other with the help of wire. We will not plug in the key. Once we assure that the connections are done and the connections are correct with the help of circuit diagram which we have, then we will plug in the key to start the experiment. So when you plug in the key, look at this. One cell is connected in the circuit and we have plugged in the key. The moment you plug in the key, you will see change in the readings of an ammeter and the readings of voltmeter. Please check. Before it was 0 reading. Now when you plug in the key and there is one cell connected in the circuit, the pointer of the ammeter and the voltmeter has changed and the reading has changed. Current has increased from 0 to certain value and potential difference has increased from 0 to certain value. I want all of you to have a look at the pointer whenever I will tell you. So please observe this carefully. Now what we will do, instead of one cell, we will connect two cells together. Now when one cell is there, we have provided potential difference of 1.5 volt. Now when we will connect two cells like this, look over here children, when you connect two cells, now how much is the potential difference? It is 3 volts. When you increase the potential difference, you will see change in the current here in an ammeter. So now look at the pointer. You must have seen that now the pointer has again changed. Current has increased and voltage has also increased. Voltage is showing a potential difference of 3 volts because we have connected two cells. One cell has potential difference of 1.5. When you connect two cells together, it will give you potential difference of 3 volt and the current has also increased. Let's connect now 3 cells here. What we are doing, we are increasing the potential difference and looking at the value of current in the circuit. So we have observed that when there is one cell, the current is some value. When you increase the potential difference, when you connect two cells, the current is increasing. Let's connect 3 cells now. When you connect 3 cells, look at the reading of ammeter. The pointer has gone again ahead. That means current has increased and this is 3 volt what our voltmeter is showing. So as we are increasing the potential difference, we can see the change in the current and the current is also increasing. Alright, let's try connecting 4 cells. So you have connected 4 cells. Meaning is that how much potential difference you have applied? One cell has potential difference of 1.5. So 4 cells means you have applied 6 volt potential difference. Look at the observation of the current. The pointer has again gone beyond means current has changed, current has increased, and here voltmeter is showing potential difference of 6 volt. So we have observed that as you increase the potential difference, the current in the circuit also increases, and this is the direct relationship between the potential difference and the current. Potential difference is directly proportional to the electric current. V is directly proportional to I. Alright, so as you increase potential difference, current increases, and this relation was first given by Ohm, so it's called as Ohm's law. Moving ahead, have a look at this. This is the ammeter which we have used in an electrical circuit. So you can see there the pointer is 0. Above 0 you can see marking 5, and behind 0 also there is a marking which will show us if the current, if we change the polarity of the battery, the current will flow in opposite direction. During that time it will correct us that your connections are not proper. So this ammeter we have used, you will see that between 0 to 5 there are 10 lines. So every line has the value 0.2. In the same way, this is the voltmeter which we have used in the circuit which I showed you in the previous slides. Here also 0 to 5, and between 0 to 5 there are 10 lines. So the value of each line is 0.2 volt. So this is called as the least count of ammeter and voltmeter. Least count means value of one line, minimum reading which you can take on ammeter and voltmeter is its least count. So the readings which we observed in our experiment is something like this. Number of cells, when only one cell was connected in the circuit, the potential difference was 1.5 and the current was 2.5 ampere. Alright. If I take the ratio V upon I, the value is 0.6. Now when two cells were connected in the circuit, during that time 2 cells is equivalent to potential difference 3 volt, and that time the ammeter showed the reading as 5 amperes. Again, if you take the ratio of V upon I in this case, you will get the value as 0.6. Then when 3 cells were connected in the circuit, potential difference is 4.5, and during that time ammeter showed the reading as 7.5 ampere. If you take the ratio V upon I, again it is showing 0.6. And finally when we connected 4 cells in the circuit, during that time the potential difference was 6 volt and the voltmeter was showing the reading as 6 volt and the reading in the ammeter was 10 amperes. If you take the ratio of V upon I, again it is equal to 0.6. So V upon I for every reading is constant, and this constant is called as resistance of the wire of the circuit. Alright. Now this readings we will try putting or plotting on the graph. Now for that we will consider x-axis and y-axis. Along x-axis we will take electric current, and along y-axis we will write our readings of potential difference. Now if you see the readings of potential difference, I can write the scale as 0, 2.5, 5, 7.5, 10 and 12.5. Along y-axis we have taken potential difference, so our scale is 0 as origin, then 1.5, then 3, then 4.5, then 6. Alright, so we have we have written the points here on x and y axis. We have written the scale on x and y axis. Let's start plotting the point. When the current is 2.5 ampere, potential difference is 1.5. Let's plot it. When current is 5 ampere, potential difference is 3. When current is 7.5 ampere, potential difference is 4.5. And when current is 10 amperes, potential difference is 6. All points we have plotted. If you try joining these points with the help of a line, you will observe that you get a straight line passing through origin. This line shows that the potential difference and electric current are directly proportional to each other. This relation is also called as linear relation because the nature of the graph is linear graph. So, potential difference and electric current, they have linear relation between them. They are directly proportional to each other. If you increase one quantity, the other quantity will also increase. Alright children, so this is the famous Ohm's law, and the knowledge of electricity begins with Ohm's law. Ohm's law is considered to be the base of knowledge of current and electricity. So the moment I say Ohm's law, the first thing we should click in your mind is V is equal to IR. V directly proportional to I. Alright. So please revise this from your textbook. You read this particular part, understand the experiment, and we will do this experiment in our physics lab also. So we will stop for today. See you all in the next video lesson with a new topic. Till then, keep revising. Take care and bye.